answer. And in further examples, I shall explain it later. And also the relationship operations to test whether the two variables are the same, or to compare the two variables. And we can use relationship operations. I shall explain through examples later on, in real examples. So let's just pass this part. So let's consider analytical operations. If you are using symbolic computation, normally the result you obtained may not be the simplest result. So we have to perform simplifications to the result. So here I shall explain to you through examples how to simplify a result. Suppose here we have a polynomial, and x should be a symbolic variable. So what we need to do is to declare x as a symbolic variable, and then input the whole polynomial in this way. And you may notice that there are 3 dots, meaning the next column, next command, or next lab command will be followed here. So the continuation symbol. So you can declare x first and extract the polynomial. Then the question is, what is the simplest form of this polynomial? By hand, you may recognize that this one can be factorized, and this one may also be factorized. We do not know it is a high order. So we do not have to worry about this. Just leave this problem to the computer, and just give a command like this simple command, and it will try different ways automatically and see which is the simplest. Normally, the one with the shortest string is considered the simplest. So what you need to do is to code simple commands. A simple command can be coded in 2 ways. I shall explain this way to you. And this is the simplest result I get. And the method used is factorization method. So in this way, we have 2 return variables. One is the simplified result. The other one is the method we use. And if we do not code it in this way, what we need to do is just give a command like this and leave it running. This is quite fast. We should already get, apart from the intermediate result, we already get the final result. And we will try different ways, different methods to simplify it. Combine method or other factorization method. And it will try all the methods. And finally, they select one of the simplest and return it back. It will try different methods. And finally, we get this one as the simplest. So we can code the simple function in these 2 ways. One way is to code it and try different methods automatically and get the result. The other one is to try different methods and get a simplified result as well as the method. If we return 2 variables, it will do it in this way. Apart from the simple command, normally you can use manually different simplification command. I would recommend to use simple command. I think it is useful. Also, we will consider variable substitution. For instance, if in the function the variable is x1, if you want to replace it by x1 star, then you can use star. And you can use the x1, all the x1s in f function by x1 star. So this is the function we use. I will give you examples later on. And if you want to substitute a few variables at the same time, what you need to do is to group them, to group the ones to be substituted by brackets, and then to group this object things by another bracket, which means that you can perform substitution at the same time. So these are quite different. Let's consider an example. For the P polynomial, if we want to replace S by X, that is simple. P1 is subs P S by X. We have to declare X first. It is simple, just to do for direct substitution. However, if we want to substitute X by this formula, S, we want to replace it by this one, by linear transformation. What we need to do? We can use a command like this. And this is not simplified result. So what we need to do is to simplify it again. And this is the result, simplified result. In this case, you can see that if you want to do it with hand, it could be quite complicated. However, in computers, you can do it in a direct way, a straightforward way. The other command, very interesting command, is to convert the result in lattice form, by calling lattice command. And here there is an example. Suppose we have a function like this, and if we want to get a Taylor series expression to it, I will explain Taylor series expression later on in the cover stuff. If we want to find the Taylor series expression, then we can use command like this. First, declare the symbolic variables when needed, A, B, C, D, and E. And then define the original function, then call Taylor function to find the Taylor series expression. And now the problem is, how can we interpret the results? The best way is to convert it into lattice form. So we can execute this kind of commands. And this is the result we get. This is the lattice string. It is even more difficult to read by ourselves. However, if you enter this part into lattice, if you run it, you can get a better form. Show you quite long. This is the result. The resolution is not